Hey YouTube and happy Thursday. I've finally gone around to recording a video that seems like it's taken a long time in coming, and it feels that way because it has. I've wanted to review my Digirule 2U since I got it last September or October of 2021. I got it along with the NanoKenbak 1 because I was very interested in these little miniature early microcomputer emulators as well as microcomputer trainers that several people are designing. They're incredibly small, help you understand how the microcomputers of the early 70s, like the Kenbak 1 that the NanoKenbak emulates, and the Altair 8800 would work. And when I first got the NanoKenbak 1, I reviewed that back, I think, in September or October 2021. But I also had gotten the Digirule 2U, and I got carried away with some other things, mainly bikes and bike reviews, and finally now got back to more computer stuff. And now that I've played with it, I'm really excited to review this. As I mentioned, I reviewed the NanoKenbak 1, and honestly, this is a lot easier to use. It's a lot more intuitive, and it also has more features than the NanoKenbak 1. The NanoKenbak 1, again, is a replica of the Kenbak 1 developed by John Blakenbacker, whereas the Digirule 2U, which is developed by Brad Slattery and Brent Hauser, is not a direct emulation of any one microcomputer, but it has many features and similar features in common with the Altair 8800 and IMSI 8080 and similar machines. Unlike the NanoKenbak 1, the Digirule 2U has a USB-C interface. It has expansion over these pads here, and because of the USB-C interface, you can use a real-time debugger. You can debug this over terminal emulator on your PC. It also uses a standard CR2032 battery for quite good battery life. This is still the original 2032 battery that I put in it, and it's still running fine. I don't think this has a real-time clock though, like the NanoKenbak 1. Anyway, so I'm just going to talk a bit about the features. I'm going to zoom in on this, and then in addition to talking about the features, I will enter in a demonstration program that I assembled using the handy-dandy ADR2 tool that Brent Hauser and Brad Slattery provide on the Digirule 2U GitHub repository. So just to go through some features, this is powered by, I don't know if we'll be able to see that there. Maybe we will. Yeah, probably not. Anyway, it's powered by a Microchip PIC 18F46K20 8-bit microcontroller. It has a USB-C interface with FTDI, FT234XD virtual COM port controller. It has an 8-bit address bus, an 8-bit data bus, 8-bit program counter register, accumulator register, status register, 64-level stack, and 256 bytes program or data RAM. 4 of those bytes, again, are for 4 registers, including the accumulator. I think the accumulator register, I know the button register, as well as the address and data LED register. I might be missing one there. 8 non-volatile memory files to back up programs, 54 instructions that are listed on the back here. I did get a 3D printed case in PETG, which will protect your Digirule 2 from any drops or other stressful handling. But unfortunately, since I did get this in PETG, I would suggest you don't do that because PETG shrinks a bit, and even though I could get the Digirule 2U into my PETG case, I'm not able to take it out. I could use a hairdryer or something, but there isn't too much on the back. So I might just print what's on the back of the ruler, the instruction set, and then some more information, and then glue that or tape it onto the back of my case. So I'm not missing too much by just having the user portion of this up top. I would have had a instruction set reference on the bottom to look at. Anyway, so it has an adjustable instruction execution interval, or an adjustable speed, 8 address LEDs, 8 data LEDs, run and stop LEDs that you can see here. Data store button, CPU run stop button, built-in debug monitor and firmware updater, an expansion port as I mentioned, with UART I/O pin on ICSP interfaces. It's powered by a 3-volt CR2032 point cell battery, and it only weighs 1.3 ounces and represents an 8-inch 20-centimeter ruler. So anyway, let's go ahead and get started with this. I'll go ahead and turn this thing on, and then you can see the startup sequence. And you can see there's run mode and run stop mode there. Go to, if I press that, goes to the address set by these buttons and listed in the data register there. There's store to store a particular value in a particular address. Previous and next to page through the memory. And then load and save from files. And I also think those are, you press those buttons when you want to communicate with a PC. Anyway, so I have a program listed up here. Let's see if we can take a look at that. One of the built-in programs, Kill the Bit. And we can see there's an assembly program here that's been listed out and then converted to machine code on the left. First we set the speed to 32, then we copy from literal to register 1 to the data register, shift right to left, I guess. Shift right to left the data register, copy register to accumulator what's in the button register, and then you take what's in the take what's in the data register and and XOR it with XOR exclusive, or operate that on the accumulator, and then copy from the accumulator back to the register, copy what's in the accumulator back to the data register, and then jump back again to the loop position here at 0.5, and then the program ends. Let's see, so then as far as different symbols here, there's the address register listed. Let me move down there, see if I can zoom in a bit. Maybe not. Yeah, the address register, the button register, I forget what C is, data register, and yeah, maybe it's address register and button register, data register, and then status register that are in the within that 256 bytes of RAM. Take a look. Yeah, so I'll go ahead and enter that in here, and then we'll play Kill the Bit, where there's a bit that's going from right to left, and you have to press a particular button as it comes across to get rid of it. If you do it at the wrong time, you get a new bit that goes through that you then have to kill. Okay, so let me just take a look here. Okay, so I'm just going to check the registers real quick here. Let's find page data register. Okay, well anyway, I know of three of the four 4 registers that are in the last 4 bytes of RAM. So let's go ahead and load this up. So I'll be pressing store after I enter in each instruction. The first one is 02. Press store. 20. Store. 05. Store. 01. Store. FF. Store. 21. Store. FF. Store. 09. Yeah, 09. Store. FD, which is 13. FD. And store, that's where the button register is. Now 1C, store FF, store 07, 4, 2, and 1, store, and FF, store, and then 28, and store, and then 05, and hopefully I didn't make any mistakes. Store, and okay, I need to go there. Oh, and it works. Okay, so there's the bit running across that will try and kill. Oh, I made a new one. And there you go. There's kill the bit. So that was really fun. I think it was a lot harder to enter programs in on the NanoKenbak, or maybe it's just been a long time and I've forgotten. But it's incredible how easy to use this is. And you can see already, you're converting binary to hex in your head, so there's some mental strengthening going on. You develop some skill in that base conversion. There's a few other built-in programs. I'll have to check. There's a Hello World program. So I'll show that next real briefly, and then I'll have another video after this, a second part of my review where I show you the tools that are available for this on the PC. And I'll demonstrate those on the PC and record that video with OBS Studio. But for now, I'll just show one more part, and I'll show you the built-in programs. These include Hello World, which displays Hello World on the terminal using ASCII art. A prime number program in file 1, so that was file 0 is Hello World. Binary to hexadecimal conversion game in file 2, a logic gate trainer in file 3, mastermind in file 4, a up-down counter in file 5, communications loopback in file 6, and then kill the bit that we're playing right now in file 7. You can find sources for these in the Digirule 2U GitHub page. Anyway, so let's try that counter. Yeah, so I'll go ahead and stop here. I'll press stop, and then I think I press and hold load. This loads, again, files from non-volatile storage, and you can save whatever you want to each of those files, but I'll use what's preloaded. Okay, and there's our counter program. Anyway, I hope this was useful to all of you. Thank you for watching the first part of my review on the Digirule 2U. I really love this device. It's amazing what this tiny ruler with just a microcontroller powered by a CR2032 cell can do to teach you about base conversions and the basics of how computers work. And the next video we'll see how you can do even more with this, developing code on a PC and then uploading it to your Digirule 2U. Thanks for watching. Please comment down below if you have this and use it, and like and subscribe as always.